Hello everyone, my name is Evagoras Lambrides from the Department of Civil and Environmental Engineering of the University of Cyprus. And today I will be presenting my MSc thesis project named Detection of Human Action and Ergonomic Risk Assessment at Construction Sites by the use of machine vision and deep learning. My presentation includes 6 parts. Firstly, I will make a short introduction to my subject, which is about health and safety in construction and monitoring the way workers work in terms of safety. I will continue with the research background, the methodology I followed, my results, summary of findings, and some conclusions. So, health and safety has always been one of the biggest problems in the construction sector, causing a large number of accidents around the world. The unsafe behavior of construction workers and the non-observance of the necessary protection measures in construction sites are the main reasons of this problem. And the uncomfortable work postures, repetitive heavy lifting, and excessive force of over-exertion are some of ergonomic risk factors that can lead workers to develop work-related musculoskeletal disorders. This is something that I will explain further in the following slides. In this chart, we can see the incidence rate of non-fatal accidents at work between 3 different job sectors between the years 2012 and 2019. As we can see with the yellow line, construction sector has the most incidents between transportation and manufacturing, which these 3 are the most 3 of the most dangerous job sectors. So having this in mind, we come to the idea for an automated method of monitoring and evaluating the way workers work on construction sites to determine if the staff are working safely and if there is risk of an injury. This method is based on computer vision and deep learning technologies and uses software code in Python to detect and analyze human activity in photos of workers at construction sites. We do something in this called, we can call it human pose skeletonizing by measuring the geometric properties of the worker's body parts and the rate of correctness of the pose according to a tool called Rapid Entire Body Assessment, REBA. So, in the following slides, we will see the 2 main topics that have to do with this method. Firstly is the work-related musculoskeletal disorders that are a group of painful disorders of muscles, tendons, and nerves that are caused by various difficult work tasks. The construction industry is one of the leading sectors in which these disorders are strongly observed, with thousands of workers worldwide showing symptoms. The most important disorders risk factors are related to lifting weights and awkward postures, and can also reduce productivity and financial loss. The other main topic is the Rapid Entire Body Assessment. This is a tool used to evaluate the risk of musculoskeletal disorders associated with a specific task within a job. And it assesses the human pose by separately rating all the body parts to specific positions and angles. And it is traditionally simple, quick, and requires a minimum equipment. Here we can see the REBA worksheet, where it is separated in 2 parts. You can see on the left the part A, which has to do with the neck and trunk and the leg analysis. There are partial ratings for the neck for these 3 body parts, and on the right side we see the part B, where is the analysis of the arms and wrist. So from the part A, we get a final score A, to the first table in the middle. You can see in the middle, and there is another score from the part B. So we get score A and score B, which contains ratings for all body parts, and with these two we get a final REBA score in the table C. So what this score means, the REBA comes with this table which show us the riskness, what every rating means. With a score of 1, we have a negligible risk, and no action is required. And next we go to scores 2 to 3, which is a low risk, medium risk, high risk, and a score of 11 and above is a very high risk, and implement change is needed. So the main idea of this research is the creation of an automated software that would receive sensory data, images, process them to recognize all body parts of the imaged person, and finally apply the REBA approach to compute the rating of, and thus the hazard in, the body posture and in investigation. Two different Python codes were used for this subject. The pose estimation was performed by the use of OpenCV and MediaPipe machine vision libraries in Python. And the aim of pose estimation code was with the use of MediaPipe library to compute and extract 3D coordinates for 33 points which correspond to different body parts. So the REBA uses only 16 of these 33 points. So re-referencing was needed. For example, we can see in this table the re-referencing I did. For example, in MediaPipe we got a body part for the left. You see the first point. For the left eye, I referenced it with the head. And for example, the other body parts to take 16 of the 33. Here we can see the whole process. Firstly, we get the worker's pose image, and then we go to the pose estimation process, where we firstly get the human joints, is the skeletonized that I said before. We go to the remapping of human joints to match the REBA reference. Rebase joints with waist as the body center, compute the 3D XYZ and the angles, visualize the pose, and export the pose in TXT and JSON formats. And the last part was the REBA score calculation process, which in this code we had the read the skeletonized pose, do the REBA calculation, the REBA assessment, and export the REBA scores. So our results, this method was applied in 10 different human poses, showing workers in a construction site, and for each we get partial and total REBA scores, which determines the riskness of the posture and how much it needs to be improved. The calculations for the final REBA score were performed by using both the code and the traditional way, by filling the REBA worksheet. Here we can see the first example. On the right, on the left, we can see the real image of the worker, and on the right image is what we get is the output of the pose estimation code. And on the table are the partial and total scores of the REBA analysis. So we get in this example we get a score A of 5, score B of B, and a final score C of 5, which means it's a medium risk posture. And here we have the manual analysis with the REBA worksheet. It is filled with the way, as I said before. We first it's completed the part A for the neck, trunk, and the leg analysis, and then the arm and wrist analysis. So we can see in the manual, with the manual method, we get a final score of 6. So we have a 1 point difference from the code. We go to the pose, the second example. Here we have a final score of 9. It's which means that it is a high risk posture. And the same with the manual analysis, with a final REBA score of 8. And the same goes for here. We have a 1 point difference. The third pose, we get in this posture, we have a final score of C. It's a medium risk posture, and in the manual worksheet, we have a REBA score of 10. So in this example, we see the big error of the code, where we have a big difference between the manual worksheet and the code of 6 points. In this table, we can see all the 10 examples that were applied in this project. The most examples have a 1 or 2 point difference, with the exception of the last part, the last posture that we just saw, with a big difference. And some summary of findings is the quickness of application and the simplicity provided by the code. It is the biggest advantage, since the method saves time, effort, and cost to the contractor through the automation of the whole process. Comparison between the code and manual results show some differences in the overall and individual REBA scores, but less often in the post-estimation. And post-estimation and REBA scores are interrelated, since the possibly incorrect estimation of the code in the post-estimation will lead to an incorrect calculation of slopes between the body parts and the figure, and therefore to the incorrect REBA score. And some conclusions. In general, the code can be considered reliable and workable, with the exception of 1 out of 10 examples studied, and the results are reasonable and expected. Errors are presented, but not to the extent that they could affect the reliability of the method. And upgrade the method of compliance and implementation of health and safety plan is an urgent in our time, and the development of technology provides us with the possibility to carry that successfully. And the ultimate goal of this project was the study of the method which with its application in the construction industry would significantly contribute to minimization of the work-related musculoskeletal disorders. So that's it for me. Thanks for your attention.